this video, I will talk about biconditional statement, and then we discuss truth table for biconditional statement. In previous video, we saw that what is conditional statement. Conditional statement look like this. If we have one proposition which is P, this implies Q. So Q is the conclusion. But from Q, we cannot go back and get, and the P is true. So let me just start with some example so that we understand what is the difference between conditional statement and biconditional statement. Suppose we have a statement written as a student will pass the discrete mathematics if and only if they get at least 50% on the end semester exam. That is one of the statements of biconditional statement. So here you can see one thing over here that is a change in this statement is if and only if. This is the statement if and only if. Before if and only if, we have one statement which says that you can only pass discrete mathematics if you get at least 50% in the end semester exam. So this statement indirectly says that if a student passes, then they get at least 50%. And the converse is if a student score 50%, then they must have passed. So it is true in both ways, either saying that the student get 50%, or if you say that if a student passes, then it means that they get 50% score. But remember that what is the difference if we say that P implies Q? P is your first statement, which is that one, and the Q is they get at least 50%. The one-sided statement does not guarantee that the student will fail as well. Suppose what happens if the student get 49%, if it is only one way. But this statement does not say anything about that. Okay, so 49% doesn't mean that the student will fail the exam. Now look at another example. Suppose that the statement is you can open the door if and only if you have the key. So it means that if we have a room and if there is a door and if the door is opened, it means that the person has a key who could able to open the door, except that there is no thief. So there is only one possibility in that case. If the door is open, then one must have a key. And if one has a key, then he or she can open the door. That is the only possibility we have over here. So it does guarantee that the opening of a door will ensure that the house owner or whatever that person is has the key. Now we talk about the truth table, and maybe truth table first, and then we talk about necessary and sufficient condition. Since we have two statements, which is P and Q, and remember that we already discussed that how many rows you are required for truth table. It is, since there are two statements, 2 raised to power 2, so we required 4 rows for truth table. So we have P if and only if Q. If P is true and Q is also true, then if and only if is also true. If P is true, then Q is false. If P is true and Q is false, then the result is also false. If P is false and the conclusion is true, if the conclusion is true, then P if and only if Q is also false. And if P is false and Q is false, this is an exception. What happened is the end result is true. Since this gives you, as I already discussed, it gives you um, unrealistic thing for that. So this was the truth table for biconditional statement. Here you can notice that in one way P implies Q when P was true and Q was false, when P was false and Q was true, P implies Q was also true. This was the case when we have conditional statement. Since the conclusion is true, so we can say that the result is also true. But here, this is not the case over here. When P is false, conclusion is true, then it is false since you have to go back from Q implies P. Okay. So this was the difference between conditional and biconditional statement. And you remember that bi means two over here. This also says that what is the meaning? In mathematics, we use necessary and sufficient condition. Necessary and sufficient condition. It is usually set for biconditional statement. So it means that P is a necessary and sufficient condition, and sufficient for Q. It can also be said like this: if P, then Q, and conversely. If it is written in mathematics like that, then you can say that it is a biconditional statement. It is also be written as P if and only if Q. Okay, these are all about the biconditional statement over here. Thank you for watching.